Hello, everyone. If we start early, we will catch up on our time. I hope so. Could we start now? I'll go outside and call people in,
Okay.
but you go ahead. And
Okay. Hello, everybody. I'm Chad Loeffler from Southwest Research Institute, and I'm going to be talking about some lessons I've learned from writing much of my own requirements on some of my projects. So the two main ones are JUNO JADE and Solar Orbiter HIS, both science instruments that have had high voltage power supplies. They've collected and processed science data. So some of the good practices I've stumbled upon are that I should associate a point of contact or some person who owns each requirement. There should be a rationale for why each requirement exists. There should be an intended operational use case for each requirement. Requirements should be noted as to whether they are high level or low level, or low level could also be derived. The requirements management tool can help a great deal. And even if we believe we know acronyms and abbreviations, we should spell them out too. So for requirements ownership, there really should be somebody who owns that requirement, a point of contact. So whenever there's a question as to what the intent of the requirement was, then the developer can go back and ask that particular person, okay, what did you mean when you write this, as opposed to something being passed along in a bunch of documents and then people guessing at what the requirement meant because nobody really knows whoever came up with it. There should also be a rationale for requirements too as to why does this requirement actually exist, what problem are they trying to solve by having this requirement. A requirement can sit on a waiting list for a long time and eventually become obsolete or overcome by events before we ever get around to looking at whether it'll go into the system or not. When the developers can look at the rationale, they can help determine if the reason is actually being met by the requirement or if the specifier has made incorrect assumptions about the system, or if perhaps a different requirement could satisfy that rationale even better. There should also be something that describes how the requirement is going to be used. We tend to have a concept of operations or ConOps document with some of our projects. This is specifying how the user intends to use the system, and sometimes we refer to an orbit in the life, where they talk about the different modes the instrument will be put into and the different data products and data rates in the different modes. The developers can use this as a sanity check to see which requirements really don't meet the intended use cases, or if there's a conflict where each requirement by itself would be okay, but when put in together, they're going to have some interactive conflict that won't meet that goal. So for requirements levels, I tend to think of requirements in terms of high level and low level. And this is different from an entire mission having, say, I think maybe 6 levels of requirements where you say, okay, level 1 and level 2 are science requirements, then spacecraft has its level, an instrument has its level, ground system has its level. Within each particular system, such as an instrument, then having a particular level in that instrument also helps a great deal. High-level requirements tend to be those that are written not in the intent of specifying technical detail, but a broad, high-level meaning, usually written by somebody who does not understand the subsystem all that well. Whereas the low-level or derived requirement is the one that is actually trying to spell out some type of technical detail and is written by somebody with some knowledge of the system. Having a good requirements tool can help in the management of requirements. So it helps to list out all the ways that you intend to work with the requirements and what the tool should do and pick something to meet that. One thing I've run into in terms of organizing and displaying requirements is that everybody likes it a different way. Some people at the higher level want to see things categorized by here are all the internal interfaces, here are the external interfaces, here are commands, here are telemetry, here are all the safety and critical requirements. And then the developer comes in and says, I'd prefer to see them by feature. If I go in and say, do a memory load or a memory dump or memory checksum, I want to see everything related to that, which could be a command, a telemetry, maybe something internal and external. Then the testers come in and they really want to see things grouped by, these are going to be tested by simulator, these by hardware, these by analysis, inspection, and test. And so depending on how they're grouped, it can be difficult to see which items are related and which ones are derived from other ones. So having a tool that can let you perhaps tag and sort and filter requirements can allow anybody to come in and say, okay, let me see everything related to memory dump or everything related to simulator testing, something like that. Also a tool that can link requirements and can find all the traces between them, can help finding holes where requirements were never flowed down anywhere or a requirement exists but was not derived from anything. So there's a vast amount of knowledge within each company and organization and group, and they may have their own set of acronyms and abbreviations they use for everything, and everybody knows what that means. Whereas passing those along into somebody from a different group or different field may cause a bunch of confusion. So always specify notation wherever possible. And then some other lessons I've learned is that while high-level and low-level requirements each have their place, putting them in the wrong place can cause a bunch of problems. So for example, when high-level requirements go down into a system without anything derived from it, the high-level requirement can sometimes take many months to accomplish without anything appearing to be burning down, and this can be problematic from an earned value management EVM perspective. And so also these high-level requirements kind of sometimes become catch-alls for a system whereby anything and everything anybody could want all falls under this requirement. And so there can be a case where it takes 1 month to go from 0 to 99%. Then we sit at 99% for another 11 months with customers asking, are we criminal or incompetent because we keep charging all this, but it looks like nothing is being burned down. So now for a couple of examples on various things for my projects. So for HIS, I did not really specify very well which of my requirements were high level or low level when I wrote them and how they related to each other. One example is memory checksum, where at the high level I say, okay, we shall have a command to check some memory. Then there were other derived requirements specifying, okay, it shall be in this standardized format, it shall have this output, it shall have this algorithm, it shall cover these areas of memory. Because that wasn't clear and the testing philosophy was take every single requirement and make it its own test case, their test case for there shall be a checksum is send the command to check some 4 bytes of anything that happens to be in memory. If the result is non-zero, that's a pass. Technically, for a requirement that just says there shall be a command, not that it shall be used or do anything, yes, that test case was correct. But looking at that, it's kind of a waste of a test case, and they could have done the more detailed testing and just covered that requirement in those. So on a lot of my projects, we have acronyms like ATP and UNIT. At the software level, an ATP is our software acceptance test procedure, which is testing the software, and a unit test is our module level, file level test. At the integration level, ATP is an abbreviated test procedure, which is testing the whole entire instrument, not just the software, and a unit to them is the entire integrated box. So when somebody comes around and says, well, has the ATP been written? Do we have an ATP? Depending on who's asking the question and who's answering the question, maybe we have one, maybe we don't. Maybe we've got a software ATP, but we don't have the box level ATP. And then something ambiguous like DPU for data processing unit. Well, okay, everything processing data could be a DPU. So for HIS, we were an instrument that was talking to a suite computer, which was then talking to the spacecraft. So technically, we were a DPU, and the suite computer is also a DPU. So early on, people were saying, well, the DPU needs to do this, the DPU needs to do that. This is all handled by the DPU, and, well, okay, which DPU is doing that? So we had to make sure all the names were unambiguous. So for the HIS side, we refer to ourselves more as the CNDH for command and data handling side of the instrument. And then the suite computer was the SWA DPU, where SWA was the suite we were part of. Okay, so coming out of college here, I tended to think of when we were talking about bits and bytes, a lowercase b is bits and an uppercase b is bytes. But to operations people at the ops level, there's no such thing as a byte to them. Everything is a bit. They only think in bits, at least where I come from. And so they tend to abbreviate things with the b, not a bit. And so there is one instance where they're drawing on a whiteboard talking about how much data capacity the spacecraft is storing for our instrument data. And so they keep writing, say, 1 GB and saying 1 gigabit. And eventually one of the scientists had to say, okay, stop, that's very confusing. Are you talking 1 gigabit, 1 gigabyte? Either make it a lowercase b or write out 1 gigabit, because somebody else is going to walk in and look at this whiteboard and be confused. We need to know whether we put the instrument in a high data production mode or low data production mode. And if we've confused on the, say, instrument and spacecraft side, are we talking about gigabits or gigabytes, then we either overproduce data and store 1/8 of it, or we underproduce and leave most of our memory wasted. So, on different systems, what size is your integer? Where we come from, our FPGA people tend to talk in things of being words, half words, and double words, where these could be thought of as short ints, long ints, or regular integers. On our 8-bit systems, the compiler just takes 4 consecutive bytes and concatenates those into an integer. So the software is written to cast an arbitrary location to an integer and read that out. Okay, everything's fine. On the 32-bit systems, if it's not 4-byte aligned, the processor throws an exception handling trap and says, no, you cannot do that. So if we're reusing software between projects, or we're reusing FPGA specs, or they specify, okay, this data bus is an integer in width, what does any of that actually mean? So we need to be very careful when we specify all these in our requirements. I'll gloss over this one here to save time, but coming out of school, I was always used to KB, MB, and GB, meaning gigabytes, megabytes, and kilobytes, and to me it was always powers of 2. Everything is 1024, kilobyte 1024, except that kind of conflicts with the international metric standard where we are dealing in thousands, not 1024s, in which case now we've got the new notation of KIB, MIB, GIB, which makes sense from a logical perspective, but can be a little confusing when passing heritage documents around between people. So on JADE, we create data products that are spin sectors. So we receive ACS information from the spacecraft and we say, okay, based on this look direction and angle, here is the sector in the sky everything falls into. And so we had a requirements wish list, and one of them on there was to fill all the data bins with a pattern. So on the ground, if we see that pattern, we can say, okay, this sector was never viewed, as opposed to it was viewed, but it had 0 counts. We had a name associated with this requirement, but he was no longer at the company when we got to this wish list, and there was no rationale recorded as to why we needed this. So it was cut from the requirements change control board, with people not being able to justify why we have it. So then we go to command the instrument to the same accumulation time as the spacecraft, and there was a little bit of wiggle room in there, perhaps 29.999 and 30.001. So now every now and again we have a sector that does not get viewed in our data product, so there's a hole in the sky map. So now the scientists are saying, okay, now we know why that requirement was on the wish list. We really, really wish we would have had it. If there's ever another change, let's put that one back in. So on the JADE instrument, we have an interface control document with the spacecraft, which is requirements on both sides of the interface, high level and low level. And so there is a requirement in there for the spacecraft to send JADE 1 transaction per second. And so that meant the spacecraft would have to queue up commands, or it would have to drop a command if they were coming in too fast. So when we got to integration testing, it turned out that if we sequenced commands 1 second apart, they could be lost. And sometimes magnetometer data we were supposed to receive in a certain amount of time was a few hundreds of milliseconds late, and it was because of this requirement about them only sending us 1 transaction per second. When I was put on the project, I was fourth or fifth person in line going into software. And so I thought they came up with this requirement. They later told me that it came from the JADE side. It may have, but there is no record as to where it came from. So if there had been some notation as to this came from the JADE side, I could have come back and said, no, this is not applicable to us, get rid of this. Or if there would have been a rationale saying something like JADE can handle 1 command per second, I could have said, no, we can handle 100 commands per second, get rid of this. So we ended up having an operational workaround and everything was okay for this. But that type of requirement ended up becoming a design driver for their interface to JADE. So if it would not have been there, they may have been able to come up with a simpler implementation for that. Okay, so for our science data products, our scientists usually talk in count rates, not total counts. They want to know if a count at some location is kilohertz, megahertz, gigahertz. They want counts per second. And so they always speak in counts per second. But if we press them, they don't really want the instrument to provide counts per second because it's not as easy as taking total counts and dividing by total time because there are instrument-specific factors, settling time of high voltage, dead time. So if software says we're accumulating for 1 second, the actual hardware is not really doing it that way. So they prefer to figure out on the ground what the actual count rate is. So knowing that what they're asking for is a high-level requirement, then I can go and specify my low-level requirement as software can provide total counts and time of accumulation and say that's all okay because the scientists have agreed to that. And then it works out better for us on both ends, even though terminology-wise, if we were to take the high-level requirement of count rates, then we'd be doing a time division on board and either accounting for settling time or dead time, which is the electronics have to process one event, and so they may ignore other events while that one is coming in. So if we were doing this on board, it would be kind of complicated, or we'd be doing it in a partial way that'd have to reverse back out on the ground. So knowing high level versus derived, we can say, okay, they can say count rate, I can deliver total counts, it's all okay. So on the HIS instrument, when we interface with the spacecraft, we have a certain message coming to the instruments either once a second or at 8 hertz. And we've got requirements that say, okay, if we do not get this message, then that's an indicator to the instrument that power could be turned off or thrusters could be firing. So make sure to safe the instrument if not receiving this message for a certain amount of time. So what does it mean to not receive this message for a certain amount of time? That was a high-level requirement, which some people knew really meant high level. So they took the approach of, okay, it makes more sense that we only lose this message if we've received it in the first place. So that was an edge trigger. My instrument and some of the others interpreted low level and said, well, they're specifying not received as opposed to lost. So not received is a level trigger. Not received, not received, not received. Okay, it's not received. And so the problem now is if we turn on an instrument without turning on that message, the instrument goes into safe mode because, well, the message is not received, as opposed to having a gate in there where it has to be received and then lost. So also in HIS, we've got data products that are high total counts and low total counts. And so to optimize getting that data down, we've got 2 different compression algorithms, one for high counts, one for low counts. In the initial draft of the requirement spec they handed to us, it was reversed, where they were specifying the high count compression for the low count product and the low count compression for the high count product. When they went back to add a rationale and reason for why they were specifying which compression algorithm was used for each data product, that's where they saw the conflict and was like, oh, okay, we just listed the high count compression for the low count product, so they fixed all those reversals, so by the time the document got to us, it was correct, and that saved them from having a bunch of data coming down, which was low resolution or less than optimally compressed. So, any questions?
Those were nice stories.
Yes.
Anybody has questions? Mike?
So with the recommendation to add rationale to every requirement, how do you avoid the situation where there's massive wall of text that needs to be read and lost within the archive system?
That is a very good question, and also one thing I've learned is that each solution to a problem then creates another problem that needs another solution. And so I don't have a good answer for that question. Sorry. Right now, I've mainly come from the projects where either we don't have a ConOps document at all, making it confusing, or we have one that kind of mixes in the requirements with it so we can kind of see the context. When I get to the point of having this 10-page of text, then I can come back with another presentation for that.
Sounds good.
Any more questions, or maybe we move to the next one? Thank you. Thanks, Chad.